In this problem, we are going to perform analysis on pneumatic cylinder cover. So, the cylinder is designed to hold a pressure of 2.5 megapascal and is generally made from aluminum alloy with the engineering plastic, which has an inch modulus of 22 GPa and a Poisson ratio of 0.3. So, what is the most concerned thing in this particular problem is we need to find out the deformation of this inner circle. And see, as per the specs, the circular deformation should be less than 10 micrometers. And if it exceeds some 10 micrometers, what happens? The airtight seal will not be there and the gas will be lost and the pressure will be lost from this pneumatic cylinder cover. See here, there is an example of a pneumatic cylinder cover and this is the part on which we are going to perform the analysis. So in order to perform the analysis on a pneumatic cylinder cover, I have opened Ansys Workbench, and once I open Ansys Workbench, I am going to go to static structure inside Ansys system and drag it and drop it on the project schematic. Now I am going to do is I am going to specify the engineering material. I am going to just double click on the engineering data cell or right click and select edit in order to open the engineering data manager. And once I open engineering data manager, as I have already told you by default, structural steel is the material that is defined. We need to change this material. So in order to add new material, you need to just click here. And once you click here, you need to enter the name of the material, that is engineering plastic. Now press enter. Now I need to define Young modulus as well as Poisson ratio. So go to linear elastic tab in the linear elastic tab or group and select unit of Young modulus as megapascal and give value of 22,000. Give Poisson's ratio as 0.3. We don't need a density, so delete it. These two are the basic properties that are required in order to perform a simple static structural analysis. So once you are satisfied with this particular material properties, then you can just close this particular tab, go to project and click on update project to update the setting that you have edited. Now our engineering data is updated. The next thing is you need to import the geometry. For importing the geometry, I am going to right click on the geometry, select geometry, update project, double click on the model to open part in mechanical module. So here is our model. Now go to geometry cell and expand the geometry cell or geometry group and you need to click on the solid. And in the definition C, as I told you by default, structural steel will be assigned to this particular body. But I need to change this structural steel to engineering plastic. I'm going to just click on the edge on this right side of this particular assignment cells. And then I'm going to get a list of materials that are available for the present analysis. So I have added in addition to structural steel, I have added engineering plastic. Now I have already created a mesh with the default mesh settings and we will see whether the quality is right or not. And then we are going to again remesh using some settings. If you want more accurate results, then we can change the settings of the mesh. So in order to change some settings of mesh, you can just set this mesh settings in the relevance. In the physics preference, I will leave it to mechanical because I am going to do a perform analysis in mechanical itself, or in the relevance I am going to do is enter 100 and just press enter. And once I have done this, see what we are going to do is we come to the statistics here. So I'm going to expand the statistics. Right now you can see the number of nodes and elements, that is 11,215 and 5,922. But now what we have done is we have changed the relevant settings from 0 to 100. Now what we are going to do is we are again going to regenerate the mesh. Again go to statistics and now you can see that nodes and elements are increased. So if you are going to refine the mesh, the number of nodes as well as the element are going to increase and the number of equations to be solved are going to increase. Now we are going to define the boundary conditions as well as loading conditions to this particular problem. So as per the specification of the problem, we are going to apply a pressure of 0.5 megapascal on the internal circular surface of this particular model. Then we need to fix the holes. In the real world, it is going to be fixed to the cylinder using the bolts. So in order to simulate that, we are going to use the frictionless support instead of fixed support. Right click on static structural, insert and select frictionless support. Now select all holes. There are a total of 12 faces that we need to select. Press Ctrl to select the multiple faces. First, second, third, fourth, fifth, sixth, seventh, eighth, 9, 10 and 11. Click here and apply. So now we have applied a frictionless support condition to all the holes which will appear in blue color. Now we need to insert pressure. I have already inserted pressure. So just select the pressure and select all internal circular faces in order to apply pressure on these faces. There are total 39 faces which you will select. Once I selected all 39 faces, click here and apply. Now I am going to give a magnitude of 0.5 megapascal and the direction of this application is normal to the surface, so it is fine. So we have applied the boundary conditions as well as the loading conditions. I am going to click on the solve. To solve this particular problem, now go to solution and insert total deformation. Now we are going to insert equivalent stress and maximum principal stress. Now select solve. Now once we have solved this particular problem, then we can select any of the option to see the result which is displayed on the graphic window. You can also change the mode of view from the edge option, but the edge option only appears when you select any one of the solution. So these are the different solutions which we have solved by applying a pressure and boundary conditions. Now what I want to do is I want to find out axial and radial stresses as well as the circumferential stresses inside this particular round cylinder. So what I need to do is I need to create another coordinate system. By default, global coordinate system is a Cartesian coordinate system. But for finding out the circumferential stress, we need to create a new coordinate system, which is a cylindrical coordinate system. So in order to create a coordinate system, what you need to do is you need to go to the coordinate system group and then right click on the coordinate system group and create a coordinate system. So once you click on this, there you will see the number of options that are related to this coordinate system that are displayed in that details of coordinate system. But here in the type, we need to change it from the Cartesian coordinate system to the cylindrical coordinate system. Now what we need to do is we need to select the geometry for which we are going to apply this particular say local coordinate system. I am going to select this inner face. Then I am going to say apply. So once you have done this thing, you can just leave it. So we have created a coordinate system, new coordinate system, and it is a local coordinate system. Now rename our new coordinate system as cylindrical coordinate system. Now go to solution and insert normal stress. So once I select the normal stress, here in the definition, there is something known as orientation and coordinate system definition. So in order to get the radial stresses, you can either use the global coordinate system or you can also use the newly created a cylindrical coordinate system. So I'm going to change this coordinate system to cylindrical coordinate system. And now see, if I come to cylindrical coordinate system, if you observe that the x direction is in the radial direction of this particular circle and then Z is in the direction of the axial direction and Y is in the circumferential direction to this particular cylinder. So by specifying or by finding out the normal stresses in three different directions, we can find radial, axial and circumferential stresses. So now what I am going to do is I am going to leave this orientation to x-axis in order to find stress in x direction, that is radial stress. So rename this to radial stress. Go to solution and again insert normal stress and rename this as axial stress and change the orientation to z axis. Insert normal stress one more time, rename as circumferential stress and change the orientation to y axis. Now right click and select evaluate all results. So here is our results, that is stresses in different axes. You can see the results in graphic window. For better understanding, you can click on animation button to see the animation of different results.